Hi, Intermaths 2A, first chapter, complex numbers. The weightage of complex numbers is 2 plus 2 plus 4 equals to 8 marks. 2 marks question, 1 4 marks question. Let me explain introduction first. Before we look at the complex numbers, let's first understand what real numbers. So real numbers means natural number system to whole number system, whole number system to integers, integers to rational numbers, rational numbers to real numbers. So natural numbers are one, 2, 3, 4, 5 and so on. Whole numbers are 0, 1, 2, 3, 4, 5 and so on. Integers 0, 1, 2, 3, 4 and so on. Minus 1, minus 2, minus 3 and so on. Rational numbers rational numbers are in P by Q form. Irrational numbers which cannot be written in P by Q form. Those are root 2, root 5, root 9 like this. Real numbers all the above. These are all real numbers. So real number system are gradually extension of complex number system because of Euler. Euler is a mathematician. Euler is a mathematician. Euler introduced the quantity I, which is called imaginary unit, with the property I square is equals to minus 1 or I is equals to root minus 1. I is the solution of x square plus 1 is equals to 0, then x square is equals to minus 1. For example, you can, when you square a number, you always get a positive number, never get negative number. Here x square is equals to minus 1. When you square a number, for example, 2 square is equals to 4, 5 square is equals to 25, 3 square is equals to 9. When you square a number, you always get positive numbers only. Here x square is equals to minus 1, then x is equals to root minus 1. It is real? No. It is not real. Root minus 1 is a imaginary unit. Imaginary unit. So, root minus 1 is equals to I. You can square on both sides. I square is equals to minus 1. I square is equals to minus 1 you can use in problems. Complex numbers are in the form of a plus ib. A plus IB. A is the real part. Real part. B is the imaginary part. Imaginary part. Real complex numbers like 2 plus 3i, 5 plus 6i, 10 plus 4i. These are complex numbers. Hamilton is a mathematician. He says, so any ordered pair a comma b is also complex number. Is also a complex number. So ordered pair of a comma b you can write like this: a plus ib. This is also complex number. A plus ib is also a complex number. Okay. See the next definition. Complex number. A complex number is an ordered pair of real numbers a comma b. The set of all complex numbers denoted by c is equals to a ordered pair of a comma b such that a belongs to r, b belongs to r is equals to r cross r. This is a relation. C is equals to set of a comma b such that a comma b belongs to r. In place of a you can take any real number. In place of b you can take any real number, that is 2. Here -1, 3. So this is a complex number. Next definition is equality of complex number. Two complex numbers z1 is equals to a comma b and z2 is equals to ordered pair of c comma d are said to be equal if a is equals to c and b is equals to d. A is equals to c means corresponding real parts, b is equals to d corresponding imaginary parts. This is in ordered pair. This is in the form of ordered pairs. You can see in a plus ib form. z1 is equals to a plus ib, z2 is equals to c plus id. If they are equal, z1 is equals to z2 if and only if a is equals to c and b is equals to c. In this also same, corresponding real parts are equal and corresponding imaginary parts are equal. For example, z1 is equals to x plus iy, z2 is equals to 2 minus 3i. If z1 is equals to z2, a equal to c means corresponding real parts, x is equals to c. B is equals to d means corresponding imaginary parts, y equal to -3. This is called equality of complex numbers. See the next definition. Fundamental operations are algebra of complex numbers. First one, addition of complex numbers. If z1 is equals to ordered pair of a comma b and z2 is equals to ordered pair of c comma d, we define addition of complex number. z1 plus z2 is equals to ordered pair of a comma b plus c comma d to be a complex number. The complex number. Addition of two complex numbers is equals to z1 plus z2 equals to, add corresponding real parts and add corresponding imaginary parts b plus d. So this is in ordered pair. You can write in a plus ib form. Let z1 is equals to a plus ib and z2 is equals to c plus id. Then z1 plus z2 is equals to addition of two complex numbers. z1 is a plus ib, z2 is c plus id. So add corresponding real parts, a plus c plus, taking I is common, add imaginary parts b plus d. This is again in a plus ib form. This is a, this is b, a plus ib. Okay, corresponding two complex numbers is equals to a plus c plus I of b plus d. Negative of a complex number. Negative of a complex number is also called as additive inverse of given complex number. The negative of any complex number z is equals to a comma b is denoted by minus z, is defined as minus z is equals to minus a minus b. Just change the symbol here. Plus z is equals to a comma b, minus z is equals to minus a minus b. This is in the form of ordered pair. You can write in a plus ib form. If z is equals to a plus ib, then additive inverse of z is minus z. Minus z is equals to minus a minus ib. This is called negative of a complex number. Difference of complex numbers. If z1 is equals to a comma b and z2 is equals to c comma d, then we define difference of complex numbers. z1 minus z2 is equals to z1 plus, you can write like this, minus z2. z1 is a comma b plus z2 c comma d. You can apply with minus c comma minus d. Difference of two complex numbers z1 minus z2 is equals to difference between real parts a minus c comma difference between imaginary parts b minus d. So this is in ordered pair. You can write in a plus ib form. If z1 is equals to a plus ib and z2 is equals to c plus id, then difference of two complex numbers z1 minus z2 is equals to a plus ib minus c plus id. Difference between two real parts a minus c plus I of difference between imaginary parts b minus d. Difference between two complex numbers is equals to a minus c plus I of b minus d. Again this is in the form a plus ib. This is a plus I b. Okay. Next definition. Multiplication of complex numbers. First of all we discuss in a plus ib form. If z1 is equals to a plus ib and z2 is equals to c plus id, then multiplication of complex number z1 into z2 is equals to a plus ib into c plus id. Multiply these two terms, a into c, ac, a into id plus ad plus ib into c, ibc, I into I square, b into d, bd. Since I square is equals to minus 1, ac plus, in these two terms I am taking I is common, I of ad plus bc, I square is equals to minus 1 minus bd. So I am writing real parts are one side and imaginary part another side. AC minus BD plus I of AD plus BC. Okay, this is in A plus IB form. So now in C ordered pairs. Let Z1 is equals to A comma B and Z2 is equals to C comma D. Then Z1 into Z2 is equals to same this formula, AC minus BD comma AD plus BC. This is multiplication of complex number. Okay, see the next definition. Reciprocal of a complex number. Reciprocal of a complex number. This is also called as multiplicative inverse of a complex number. The reciprocal of any complex number z is equals to a plus ib not equals to 0 is denoted by 1 by z. A plus ib not equals to 0 means we are finding reciprocal, means denominator should not be 0. When it is 0, the expression becomes undefined. See, 1 by z is equals to 1 by z is a plus ib. A plus ib. This is not in a plus ib form. This is in 1 by a plus ib form. So you can do rationalizing factor here. A minus ib by a minus ib. 1 by z is equals to a minus ib by a plus ib into a minus ib. Here we have one formula, a plus b into a minus b is equals to a square minus b square. A square minus I square b square. 1 by z is equals to a minus ib by a square, since I square is equals to minus 1. I square is minus 1 apply here. So minus 1 minus plus b square. 1 by z is equals to a by a square plus b square minus b by a square plus b square minus, you can write like this, 1 by z is equals to a by a square plus b square plus I of minus b by a square plus b square. This is in a plus ib form. Okay, this is a plus I, this is b. This is reciprocal of a complex number or multiplicative inverse of a complex number. This is in a plus ib form. Now you can see in ordered pair a comma b, or z is equals to a comma b. 1 by z is equals to multiplicative inverse of complex number is equals to a by a square plus b square minus b by a square plus b square. This is called multiplicative inverse of complex number. Now see the next definition. Division of a complex number. If z1 is equals to a plus ib and z2 is equals to c plus id, c plus id not equals to 0. We are doing division. Then z1 by z2 equals to a plus ib by c plus id. C plus id not equals to 0. This is in the denominator. So denominator should not be 0. Multiply the numerator and denominator with conjugate of denominator. z1 by z2 is equals to a plus ib by c plus id into c minus id by c minus id. Rationalizing factor. So multiply these two terms. A into c, ac. A into minus id, minus I ad. ib into c plus ibc. I into I minus I square, b into d, bd. A plus b, a minus b is a square minus b square. So c square minus I square d square. Since I square is equals to minus 1. AC, in these two terms I am taking I is common, plus I of BC minus AD. I square is equals to minus 1. So minus 1 apply here, minus minus plus, plus BD by C square. I square is minus 1. So minus minus plus D square. So real parts are, I am writing real parts are one side, AC plus BD plus I of BC minus AD by C square plus D square. That equals to AC plus BD by C square plus D square plus I of BC minus AD by C square plus D square. This is division of a complex number, Z1 by Z2. So this is in A plus IB form. Now you can see in ordered pair. If Z1 is equals to A comma B and Z2 is equals to C comma D Z1 by Z2, division of a complex number. Z1 by Z2 is equals to AC plus BD by C square plus D square, BC minus AD by C square plus D square. This is the formula for division of a complex number. Okay, so introduction part is completed. If you have any doubts, so please comment me, share, like, subscribe for more videos.